Hello friends, this is Jim with Science Talk. I'm going to, in this video, discuss water vapor. And this is from a study that came out about a decade ago. And reason why I'm talking about that is because we don't see a lot of studies that look at water vapor in conjunction with other greenhouse gases. Most studies just look at water vapor's contribution. The IPCC will discuss water vapor, but certainly not to a great extent. And don't get me going on how they basically neglect methane. That's a whole other issue. But the thing here is that we're going to talk about the distribution of atmospheric water vapor, H2O in gaseous form, which is a significant greenhouse gas. And how it's distributed across the planet varies widely. So the study that was done in 2008 wanted to address what is the extent of the contribution of water vapor to global warming. In other words, okay, yes, it's a very abundant greenhouse gas, probably most abundant, at least at the time the study was done. The study used at the time recent NASA satellite data, and researchers were basically able to estimate better the heat trapping effect of water in the air, which validates its role of the gas as a critical component of climate change. So, Andrew Dessler and his colleagues from Texas A&M in College Station indeed confirmed that heat amplifying effect of water vapor is potent enough to double the climate warming caused by increased levels of CO2 in the atmosphere. Okay, full stop right there. What does that sentence mean? Heat amplifying effect of water vapor is potent enough to double the climate warming caused by increased levels of carbon dioxide in the atmosphere. In other words, water vapor by itself will have an effect. Carbon dioxide by itself will have an effect. Put the two together, and you have the synergistic effect, which will amplify the effect. It'll be like a combined effect, but more so. So whatever heat trapping ability CO2 has, the presence of water vapor will double its ability to trap heat. So these two are working synergistically together to actually basically exacerbate the situation. So what did they do? What did these scientists do precisely? They used data from the Atmospheric Infrared Sounder, acronym is AIRS, AIRS, on NASA's Aqua satellite to measure precisely the humidity throughout the lowest 10 miles of the troposphere. Atmosphere. Well, the first layer is called the troposphere. That information was combined with global observations of shifts in temperature, allowing researchers to build a comprehensive picture of the interplay between water vapor, carbon dioxide, and other atmosphere warming gases. This research project, was funded by NASA and was published at the time, in 2008, in the American Geophysical Union's Geophysical Research Letters. Dr. Dessler says, everyone agrees that if you add CO2 to the atmosphere, then warming will result. The real question is, how much warming? And basically what they are suggesting is the answer can be found by estimating the magnitude of water vapor feedback. Increasing water vapor leads to warmer temperatures, which causes more water vapor to be absorbed into the air. Warming and water absorption increase in a spiraling cycle. Translation, positive feedback loop. Water vapor feedback can also amplify the warming effect of other greenhouse gases, such that the warming brought about by increased CO2 allows more water vapor to enter the atmosphere. There's your mechanism. The warming effect of other greenhouse gases by increased CO2 levels, allows more water vapor to enter the atmosphere. The warmer the air temperature is, the more water vapor it can hold. That's basically, and so CO2 trapping heat, hey, warm up the atmosphere, hey, we can now put more water vapor in there, further warming things. Now think about it. For example, up here in the Arctic, especially in wintertime when we get like 3, 4, 5 hours of sun, where the sun's above the horizon, but the angle of the sun and the angle the rays come is such that when we measure the heat, watts per square meter, or in joules per square meter, is really not sufficient to really warm things up. What usually determines temperature at high latitudes is cloud cover. Clear night, boom, it's going to be cold. Clouds move in, it warms up. What are clouds? Water vapor. Right? So you can see, where they're going with this. So Dr. Dessler also says the difference in an atmosphere with a strong water vapor feedback and one with a weak feedback is enormous. Climate models have estimated the strength of water vapor feedback, but until now, the record of water vapor data was not sophisticated enough to provide a comprehensive view of how water vapor responds to changes in Earth's surface temperature and atmospheric temperature. And basically that was due to not having appropriate instruments sensitive enough to take those measurements, to collect that data. Now, thanks to ERS, we can, and now we're getting data. Dr. Dessler says, this new data set shows that as surface temperatures increases, so does atmospheric humidity. Dumping greenhouse gases into the atmosphere makes the atmosphere more humid, and since water vapor itself a greenhouse gas, the increase in humidity amplifies the warming from carbon dioxide. There's that synergistic effect at play. And remember, warmer air holds more moisture. Specifically, the team found that if Earth warms 1.8 degrees Fahrenheit, that's 1 degree C, okay, the associated increase in water vapor will trap an extra 2 watts of energy per square meter. How many square meters Earth's surface have? That's a significant amount. And Dr. Dessler indeed goes on to say, okay, that number may not sound like much, but add up all that energy over the entire Earth's surface, and you find that water vapor is trapping a lot of energy. We now think the water vapor feedback is extraordinarily strong, capable of doubling the warming due to carbon dioxide alone. Erica Fetzer, who is an atmospheric scientist who works with the ERS data at NASA's JPL in Pasadena, Cal, said this study confirms that what was predicted by the models is really happening in the atmosphere. Water vapor is the big player in the atmosphere as far as climate is concerned. But once again, the models do work. Now, people are going to say, the deniers, are going to say, well, the water vapor, you have evaporation, that's where the water vapor coming in. True. And you have transpiration from plants. True. But when you combust gasoline or diesel, the product is not just CO2. The product is CO2 plus water. So what comes out the tailpipe is CO2 and water. So burning the fossil fuels is adding not just CO2 to the atmosphere, but water vapor to the atmosphere. Oops. So that's you look at any basic gasoline is basically an alkane, which is a hydrocarbon chain. Hydrogen and carbon put together. All the carbons single bonded to each other, and therefore, if you wanted to know the formula for any such generic alkane molecule, it's CnH2n plus 2. In other words, if you take octane, octane is a 8-carbon molecule. Well, 2 times 8 is 16 plus 2 is 18. So the formula would be C18H18. And then you add oxygen to combust that, and your product is going to be CO2 and water. Multiply that by how many millions of vehicles in use on the planet. So when we burn fossil fuels, we're adding 2 greenhouse gases to the atmosphere, CO2 and water vapor, not just CO2. So, one other thing, we hear about a lot of these renewable systems, and they're good. Right? We do need to stop burning the fossil fuel, but it's not going to be the panacea immediately, because a lot of these proposed methodologies are going to add water vapor. Now, the advantage is water vapor, you can increase precipitation, but as I have discussed with you guys before, dry areas become drier, wetter areas become more wetter. So dry areas become drier, wet areas become wetter. So the precipitation will not necessarily be evenly distributed, and it could, instead of coming in small incremental amounts, it could come all at once, creating flash floods, erosions, and all other sorts of issues. So just another example of going back to the unintended consequences. So I wanted to bring, as I said, this is from 10 years ago, but you know what? Just because it's not the most recent doesn't mean it's not relevant study. And this basically, they were able to demonstrate the importance as well as some mechanisms of how water vapor works. And as it turns out, the combination of CO2, CH4 as well, holding in heat that allows more warmer air, can hold more water vapor. So now you put more water vapor in the atmosphere. Water vapor is a greenhouse gas trapping more heat. So now the two work together to really create this positive feedback loop. So I found that to be an interesting study and something I wanted to share with you. So thank you for watching and for your time, and we'll talk soon. Hey folks, this is Jim here reminding you to subscribe to this channel, to share my videos, tell others of the work that I do here. I also ask that if you are not already a patron at Patreon, to please consider becoming a patron at Patreon. You can find the information in the description box below the video. I'm asking you to help support the work that I do. I do not take any money from corporations or from any other sources, so the information I share with you is the actual science as it comes out of the peer-reviewed journals. So there is no BS, there's no propaganda, there's no agenda. It's just I present the science and I explain to you what it means, or at least my interpretations of it, based on my own experience as a scientist. I want this channel to grow. I consider, while I discuss many different topics here, you notice I do focus a lot on climate issues. I consider climate change to be the most pressing issue facing humanity today. Thus, I consider it important to disseminate this information to a wider and wider, more and more people. And I need your help to do this. So, yes, please subscribe. Please tell others of the work that I do here. Please share my videos on social media platforms, with your social media groups, what have you. we need to get this information out there. So for those of you who are supporting me on Patreon, I thank you greatly for your support and continued support. It does mean a lot to me. So together we can get this information to more and more people. Thank you. Thank you for your support.